I think the learning outcome or the learning benefits are huge. I think it's very hard to put a monetary value on that. The skills that you develop from this sort of stuff is hard to quantify with a monetary value, but I think it's still significant. Certainly in my case, I don't think I would be a lead data scientist as opposed to just a normal data scientist had I not really focused or spent the time working on this.
Welcome to another episode of the Mapscaping podcast. My name is Daniel and this is a podcast for the geospatial community. My guest on the show today is Adam SYMINGTON. So Adam does a bunch of different things. He has a PhD in computational chemistry. He works for a geospatial company as a lead data scientist, and he makes beautiful maps using Python. So we're going to be talking about a mixture of those things today. But before we dive into the episode with Adam, I've got a little bit of housekeeping. So firstly, I'm publishing this episode a little bit later this week. I've been sick with COVID for the last few weeks, and it's played havoc with my recording times. And so if you're wondering why this episode is a little bit late, that's the reason. Secondly, I discovered an email newsletter the other day that I don't think I included in a very recent episode about open source intelligence or open source geospatial intelligence. So if you enjoyed that episode, I think you'll love this newsletter, and you might find this newsletter interesting anyway. It's called actualcontrol.substack.com. I'll put a link to it in the show notes, but it's really well written, really enjoyable to read, and incredibly well researched. I think it's worth your time. And the last thing before we get started, I want to say a huge thank you to everyone who's decided to support this podcast on Patreon. So today, this podcast is sponsored by you, the patrons that have taken the time to help make this possible. So the most recent sponsor or the most recent supporter I want to give a big shout out to is Forest Pound. Thank you very much. It really makes a difference. And I think we hear people say that all the time, this really makes a difference. But until you've tried to create something like this on a regular basis, it's probably pretty hard to understand what a difference it makes. Just a little bit of help. So what your support on Patreon means is that I can afford to pay for some of the things that cost money when you're making a podcast. But there's also that feeling of exchange of value, like feeling like, wow, I made something that people see value in, that is incredibly motivating. So there's the financial side of it, and there's that motivating factor that comes with keeping score by exchanging value in this way. So I'm ranting a little bit, but I guess what I want you to understand is that I am incredibly grateful for your support. If supporting this podcast is something that you might be interested in, I'll put a link to that in the show notes. Okay, thanks very much for your time. Let's get into the episode. Hi, Adam. Welcome to the podcast. Really great to have you here. You are a lead data scientist, and you also have a PhD in computational chemistry. You make beautiful maps using Python. So you do a bunch of different things. You've come a long way in your journey. I think just before we dive into this conversation, would you mind introducing yourself to the audience, please? Perhaps letting us know how you got involved in geospatial, how you went from a PhD in chemistry to working as a lead data scientist and using geospatial data.
My name is Adam. I'm a lead data scientist, and I work in a tech company in the UK called Geospatial. I did a PhD in chemistry at the University of Bath in England, and then I spent a couple of years working as a postdoc, so just a full-time researcher, again in sort of chemistry and physics. And then I decided that academia just was not for me. There's too much. I couldn't hack it any longer. And like any relatively mathematics-y heavy PhD graduate, I went into data science after I finished academia. At the time, I applied for a couple of different jobs, didn't really get anything. This was actually just as COVID was starting to, it was at the end of the first lockdown in the UK. So jobs were still a little bit scarce at this point. So I applied for a few jobs, couldn't really get anything. And I was mainly looking in sort of traditional industries like insurance, banking, the classic evil industries, I guess. And then a job opportunity came up in a company called Geospatial, which is a geospatial intelligence company. I had no idea what they did, but I applied for the job anyway because it sort of seemed like geospatial intelligence sounds quite interesting. So I applied for the job, didn't get it actually in the end, although they advertised a few weeks later for another position, and then they contacted me and said, we really liked you the first time round, so we'd like you to apply again. I did, and then I got it on the second go. And then I was working in the geospatial industry, basically. So what we do is we use AIS data to track ships around the world. So everywhere at any one time, there are ships. There's like 300,000, 400,000 ships transiting the world. These could be oil tankers, container ships, fishing vessels, and they are constantly broadcasting their position, so where they actually are. This data is collected and made available to whoever wants, well, whoever can pay for it. And we use that data to try and gain insights into the shipping industry, which we then obviously try and sell. I was sort of thrown in at the deep end and told, here are a number of illegal activities that shipping operators are currently engaged in. Can you use this data to identify, from sitting in your bedroom in Bristol, can you use this data to identify when an oil tanker in the Persian Gulf has gone and taken on some cargo that it shouldn't have done? Or can you identify when a fishing vessel is fishing in an area where it shouldn't be fishing? And all of these sorts of things. So I went from, simulating chemical reactions to tracking down stolen oil tankers or tracking down illegal oil shipments in the space of about 2 weeks, which was pretty intense. And that's how I got into geospatial.
What was the hardest bit about getting into this geospatial side of your job? Because it doesn't sound like you had a great deal of understanding of it before, maybe not even the language around it. So a lot of what you said before seems to me it could be solved using geofences, that kind of thing. But that's something that you had to learn, I'm assuming anyway. What was the biggest hurdle for you, the biggest barrier to entry when you started work in terms of your geospatial understanding?
It was just having zero experience. So I would preface this by saying, like, what I did in my PhD and in my academic career was we ran simulations of how atoms moved around in materials. This was particularly aimed at batteries. So in a battery, a lithium atom will move between the anode and the cathode when it's charging and discharging. I built simulations to track that movement. At the end of the day, all that is just XY coordinates in a file that get updated continually as the simulation progresses. And what I'm doing in my current job is looking at how lat longs are changing over time. Basically, the mathematics and the principles behind them are the same. It's just the problem that they're being applied to is different. So, what I found hardest was understanding the problem that I was trying to solve because I was coming in with 6 or 7 years of understanding in one particular field and having to understand a new field pretty much instantly. You're absolutely right. A lot of it is geofencing. A lot of it is also there's a lot of context behind it. So, for example, two ships can meet at sea, and one ship could be a sanctioned oil tanker, and it could throw a hose over the side into the other ship and offload its cargo or its oil. That ship can then sail elsewhere and sell that oil as if it's legitimate. Understanding when that happens, when it is illegal, versus that can often happen for legitimate reasons. And hence, understanding the context behind the problem that was trying to be solved was very difficult.
What about tools? So I know that you do a lot of work in Python now. Is that something that you had a lot of experience with before you started working at your current job?
Yeah, so everything I did in my previous job and in my PhD was basically all in Python. So all of the simulations that were being run, they're using sort of old, bulky Fortran and C code, the outputs of which are just huge text files, literally are huge text files that need to be parsed. There were tools that existed already to solve quite a lot of the problems that we were trying to solve. However, Python is really, really nice in that you can parse a huge data set, you can analyze all of the data that's within it, and then you can get a really nice, like eye-catching visualization in the space of one piece of code. And so being able to do all of that in one was really appealing. So I just took a bit of a hit and spent evenings for about 6 months learning how to write Python in the first year of my PhD. And then after that, just applied it to every problem until I could do it competently. And by the end, like I was developing my own analysis packages, publishing them on GitHub, on pip, and even publishing some of them in open source software journals. So over the course of like that sort of 4 or 5 years of like my initial sort of academic career, I went from being a complete beginner to like quite expert in Python. And it was mainly because of how versatile it is. It was just a very, very useful language to apply to these particular problems.
So when I talk to people in the geospatial world, like Python comes up again and again as a tool that you need to know. It's, once you understand this, you can apply it to so many problems and you can apply it to so many different subject domains as well. When you think back to when you were learning Python, what worked for you? Was it books? Was it online tutorials? Was it having certain problems to solve? Did you have someone that could help you along the way? Can you remember what really made a difference for you in your learning?
So I initially tried to read a book, and that gave me the basic pointers, which I think everyone needs to do, to be honest. Like, I think everyone needs to take some sort of, whether they read a book, whether you do an online tutorial, I think everybody needs to do just a basic foundation, like just to understand what a function is, what a variable is, the really basic stuff. But for me, after that, then I needed to solve problems. I'm so bad at dedicating time to solving like a pre-made problem. Like you can get all of these tutorials that will teach you how to do X, Y, and Z. But I personally find them very boring because it's not a problem that I necessarily want to solve. Like, I don't want to write a machine learning model to predict, I don't know, the size of a particular flower given the time of year, or whatever or the size of butterfly, or the pattern of butterflies' wings, or whatever the examples are. That just doesn't interest me. I need to be able to apply something to a problem that interests me. So in my case, I just had a load of problems in my PhD itself that needed to be solved. So I just wrote some Python to do that. And then getting onto the geospatial stuff, I really enjoy this work. I find it really interesting. And hence, it's not really been hard to go, well, it's been hard, but it's not been a challenge, or a struggle, rather. It's not been a struggle to go away and try and learn these new technologies, because I'm applying them to problems that I find really interesting. And I actually do think that, like, that's the piece of advice I give to most people who ask me about Python is find a problem that really interests you, or find something that you really want to do, and then use that as your way of writing code. Because it's just so much easier to learn on the job. It's so much easier to have something that you're really passionate about, that you're really interested in, as a way of learning. I'm sure we'll get onto it a bit later, but that is like Python maps, making beautiful data visualizations of geospatial data is how I basically learned all of the skills that I'm now using in my current job.
Yeah, I definitely want to talk about your work with map visualizations later on. You said something that was super interesting. It was learning on the job. How much room is there for you in your current job to learn on the job? You know what I mean? To experiment and to try things. Is that room made for you, or do you have to create it for yourself?
So Geolect is really fantastic at providing support for learning. Like, Geolect is a startup, and it has to, you're competing with other bigger companies. But I think one of the things that any good company realizes is that you have to invest in your staff in order to get the best out of them. And at the end of the day, so there's 4 data scientists at Geolect. 3 of them have PhDs in different academic fields. One of them's got a master's in data science. And so we all came into this with quite different skill sets. That, I think, is beneficial in the one sense, because having one problem and having 3 people approaching it from a different point of view can often lead to quite interesting solutions. So that's really beneficial from the business's point of view, but also from a business point of view, like motivating your staff and giving them free time to actually, or freedom to go away and upskill, is only going to benefit you in the long run, because they are going to become better, more skilled data scientists. So whenever that big, 1 in a million problem comes down the line, you've got the team in place that can actually solve it. And that is something that GeoLex is actually very good at when it comes to their staff, is letting them, or giving them the freedom to actually go away and learn. So I've had so much freedom when it comes to Python maps. I'd like to spend some time learning these new technologies so that I'm able to apply it to the job. And so much of what I've done with Python maps, I'm now applying in my day job.
Okay, we've alluded to it a couple of times now. Could you tell me what Python Maps is? Because you've talked about this AIS data, you've talked about data visualizations, we've talked a little bit about Python itself, and we've mentioned Python Maps a few times now. What is Python Maps?
So Python Maps it was originally my lockdown boredom project. I have a Twitter account called Python Maps, or a social media presence, which I call Python Maps. And on social media, I post what I think are interesting and possibly even beautiful data visualizations of geospatial data. So I take geospatial data sets and I try to make really pretty and eye-catching visualizations of that data. So my favorite example is using AIS data to generate a shipping lanes map. What you can actually do is, if you take enough AIS data points, so billions and billions of location broadcasts from ships, if you take all of that information and you build a histogram of it, you can build a really beautiful image of the world's shipping lanes, so where ships actually transit. And you don't even have to overlay a map of the world. The coastlines just spring out from that image. I think it's a really, like, quite a powerful data visualization. it's able to show off a particular form of data. Like it summarizes this huge data source into one single image. And that's kind of what I do with all of my visualizations. And Python Maps is, it's basically my hobby in that respect.
And what Python libraries do you use to make these visualizations?
It's a good question. Originally, it was just GeoPandas and Matplotlib. Matplotlib is, go back to my academic career, Matplotlib is one of the reasons why I started learning Python, because it makes, originally, like in my research group, everyone used Excel to make their plots. And you can make nice plots in Excel. However, it's going to take you 3 or 4 years. And, who's got time for that? Matplotlib, rather, is quite nice in the sense that you can generate quite nice plots quite quickly. And also, of course, again, I sort of alluded to it earlier, you can blend it into your analysis script. So you can do the entire data processing, data manipulation, data analysis, data visualization in one job, which is really nice. So I learned Matplotlib in my academic career and used it religiously throughout. There are other libraries that now exist that do plotting. I'm sort of a bit of a purist and I love Matplotlib because of how versatile it is, which I can maybe get onto in a minute. So I used at the beginning, I used Matplotlib a lot, and I used GeoPandas. GeoPandas is a good library for processing geospatial data, and it's got a lot of capability for reading and writing geospatial data. So if you get a shapefile or a GeoJSON, GeoPandas is very good at processing that. So I used those two originally. As time went on, and I started becoming a little bit more competent with other data sets. So for example, rasters, I used libraries like Rasterio or RioX which are libraries designed to parse raster data. I've not really strayed that far away from those libraries. I actually think, in terms of geospatial data science and, of course, visualization, those four libraries and other things, maybe like Shapely, and that's probably it actually, as far as what I use. So I try to keep it simple because, also, of course, the more commonly used a library is, the more information there is online. So the easier it is to learn, and also the easier it is to debug what you've done. I've been quite lucky in the sense that I'm able to go away and like debug issues on my own, but I'm quite lucky in the sense that a lot of the problems that I've solved have already been are well-known issues that happen with these libraries, and so there's a lot of information that already exists online.
Yeah, that makes perfect sense. But you talked about some rather large data sets. I think you said something with 8 billion points or something like that. What kind of environment are you running this on? Is it somewhere in the cloud or on your own machine? What does your environment look like?
I just run this on my own laptop. There's definitely not the correct way to do it. So at work, for example, we run everything on AWS. So all of the really, like it's a commercial environment. We need to be quick with what we do. You can't have long load times and long code execution times. We use AWS, and everything scales quite nicely that way. As far as data visualizations are concerned, in my spare time, I'm not really that bothered about how long something takes to run, because I can set something up to run and then I can go for a run or I can go make dinner. I haven't quite got to the point of investing in some sort of cloud computing resource to be able to process this stuff. The AIS one was it was probably the worst in the terms of the sheer amount of data that was being used. But there are some other data sets. So I think there's a data set called Hydroshed, which is a rivers. Well, it's more of it relates to all things water. Within it, there is a rivers data set where they have used topography data to derive rivers. So looking for basically like river valleys from topography data. And they've used this to generate what they would call every single river that exists on Earth, whether it has water in it or not. So, for example, if you plot this data set, it looks like the Sahara looks like it's wet because there's lots of dried up riverbeds throughout the Sahara from when it was green. But in reality, there's no rivers there. So there's billions and billions of line strings, like quite long line strings in this data. I remember when I first tried to parse that data set, my laptop just crashed. So there had to be some clever ways. I had to come up with some clever ways around this. So, for example, filtering out, having a little bit of contextual understanding of the data that you're working with. So knowing that, well, actually, so with this particular data set had lots of metadata associated with the lines, which related to the average discharge of the river, the width, depth, all of that sort of information. So it was possible to derive a way of, or come up with a way of filtering out non-existent rivers or finding those dried up riverbeds from those numbers. And then that filters down the data to sort of a manageable size, and you can make quite a nice river map. So that was a particularly difficult one. Some of the topography maps that I've made as well, because they are the data source that I use, which I can't actually remember off the top of my head, is quite high resolution. The data sets are massive, and hence it's quite, sometimes you can run into difficulty with, like, for example, I tried to make a topography map of the US, and my laptop started to complain a little bit because the US is quite big, right? As far as environments are concerned, I do everything on my local laptop. I think you can get away with a lot more than you realize just on a standard piece of hardware.
So what I'm hearing you say is that you do this because you're passionate about it, you want to learn, you keep it pretty simple, you stick to the libraries that you know, to the tools that you understand, you run it on your laptop and you're using open source data. And you're also publishing these things. So we mentioned this Python maps, your brand, if you will, your social media presence. What has been the result of publishing these maps on Twitter? And I know you also publish some on Reddit, but what do you get out of that?
So to give a genuine answer, I do actually love the attention that I get from it. I really enjoy posting these things and getting, on Reddit in particular, thousands and thousands of likes. It's quite a nice sort of, for me, I make the maps because I enjoy the visualization, but I really do also enjoy the validation of a good job. To go a little bit more cliched, I think feedback is really important. So one of the things I've looked back at the maps that I made at the beginning, and I find that they're nowhere near as good as the maps that I'm making now. And a huge part of that is actually understanding where flaws are and correcting those. And from posting the maps online, you just open yourself up to, in the case of Reddit, actually, thousands of people, thousands of opinions. And you're always going to get negative opinions, but it's quite useful to actually read those negative opinions because you get a sense for what you're doing wrong, or indeed what you're doing right if it's a positive opinion. And I think that's really useful. I do a lot of data visualization in my day job. And I find that actually my skill set there and the visualizations that I'm producing there have improved immensely because of the improvement that I'm getting from my hobby, essentially. And I put a lot of that down to the feedback that I get and the feedback that I can then act on.
So, we've mentioned that this Python maps, you call it your social media presence, your brand. Why did you decide to call it Python maps? Why not use your own name?
Because it's a good question, actually. So at the beginning, it was just a little hobby and it was just a way of upskilling in that particular area. I think there's probably a little bit of a fear of putting yourself out there because that's what you're doing. You're putting your head above the parapet and you're sort of opening yourself up for criticism. And, I thought, part of me, I think, thought that it was maybe a little bit, a little bit embarrassing to be doing that and to be posting about it online. I have since rolled back on that because I've received quite a lot of positive feedback. And I've started writing about writing tutorials on Medium and towards data science for how to produce certain maps, how to analyze data in a certain way. And I've received quite a lot of positive feedback, and I've decided that's when I sort of decided to maybe put my name to it, if you will. But I think at the beginning it was kind of just out of fear for failing, to be perfectly honest, and looking stupid in doing so, which is a flaw. Like you shouldn't. I don't think anyone should approach life like that. Having said that, I'm quite glad I did it because I think Python Maps as a brand is quite cool and it kind of removes my personality from it. And it can just be teaching people how to generate cool maps, like how you can process geospatial data, different analysis methods, things like that. And I think you can sort of take me out of it and it can just exist as a standalone, learning piece. Like people could actually go and read the stuff that I've written, they can see the stuff that I've done and hopefully be a little bit inspired by some of the visualization or even just learn something from the writing.
So yeah, I can completely understand what you're saying there. I think for me, if this were like my social media presence on Twitter anyway, is mapscaping. It's not me. And I think at the start it gave me that buffer, right? Like it wasn't me personally. If you thought this podcast sucked or whatever it was I was doing on social media at the time, it was no good, if you disagreed with me, you weren't disagreeing with me personally, you were disagreeing with this mapscaping presence thing. And it gave me that buffer and it made me maybe a little bit braver, a little bit more prepared to put myself out there. I think now, when it's working, if I could go back in time, I would rather have that brand attached to me as a person. I think I personally would get much more benefit out of that. And I think people are more willing to connect and engage with a person as opposed to a brand. But I can definitely understand the arguments for and against this.
I do agree with your point about getting more benefit from it if you'd attached it to you as opposed to going solo at the beginning. But I think your point about buffer is absolutely correct. It is quite nice to have a buffer between you and the work that you're doing that you can sort of hide behind. I do stand by my point about like who cares? Like if people don't like it, they don't like it. If you're doing something that you enjoy, and in this case I do enjoy it, you clearly enjoy your podcast. Like who cares? Who cares if people don't like that?
Yeah, I think just at the start, when people are trying something new, it's okay to have that buffer. If that's what it takes to get people going, to get them motivated. I mean, look at the benefits that you've got out of this. You've mentioned it's bled over into your job. You create better visualizations now. You've created this following, this brand on these different social media platforms that you use. So the benefits are there. And if you need an easy on ramp, and if that is that little bit of buffer, that little bit of space between you and perhaps the negative criticism that might come the other way, then I completely understand that.
Yeah, I agree.
So I'd be curious, are there any other benefits that have come out of this? Because people will look at this, go, yeah, great, I got better at my job. Awesome. I was getting paid anyway, and I'm still getting paid afterwards. Can you talk a little bit more about the return on investment? Because you are investing a lot of time into this. Have there been any other opportunities that have presented themselves because you started this project, because you put yourself out there, because you are showing your work?
I think the learning outcome or the learning benefits are huge. I think it's very hard to put a monetary value on that. The skills that you develop from this sort of stuff is hard to quantify with a monetary value, but I think it's still significant. Certainly in my case, I don't think I would be a lead data scientist as opposed to just a normal data scientist had I not really focused or spent the time working on this. And of course, I could have spent the time working on this in other ways. Like I could have just done tutorials and not put myself out there. However, I find this is quite a nice motivation to actually go and do things. It's quite. I genuinely would spend there'll be times when I'll be just sitting watching TV, but I'll have my laptop in my lap, playing around with a particular visualization, playing around with a particular analysis method, just to see what I can do. I don't think you're going to do that unless it's something you're passionate about. So in my case, I would say that it's hard to put a monetary value on the skills that you learned. On top of that, quite a lot of other opportunities have sort of popped up. So at one stage, I was thinking about actually selling the prints of the maps. I get quite a lot of requests to do that. However, in that case, that's something I might do in the lead up to Christmas just to see what happens. However, I do wonder how much money I could actually make from it. It still would be a fun experience, and that's another point to make: is that experiences are still, again, hard to put a monetary value on it, but like life experience is just important to have in general, and it's a fun story even if it doesn't work out. The other one is I do get the occasional request around sort of freelance data visualization work. So to tell a story, I'll not name any names, but the CEO of $1 billion company messaged me, just DM'd me on Twitter recently and said, love the work that you're doing. We're working on something similar. We want to make some similar visualizations for one of our products. Do you mind if we have a chat about potential collaboration? So I was like, yeah, yeah, why not? So things like that do come up, and that comes from sort of the social media attention. So like as your followers grow, what I've noticed is, or as my followers grow, what I've noticed is the number of messages that I get and the number of sort of requests that I get have started to slowly increase. I haven't necessarily seen any, again, monetary value coming out of that yet, but who knows what will happen in the future. And again, like I may not even act upon them. It just depends on, my situation at the time. Like I wouldn't necessarily be too worried about planning where that return on investment is coming from. It's been more of a journey for me than an actual goal, if that makes sense.
Yeah, it does make sense. If you had to apply for a new job today, tomorrow kind of thing, would you include your work with Python maps on your CV? Is this something that you would put forward to an employer and say, look, here is some of my work. I did this. How would you present that to them? I guess my question here is like, what do you think the value and potential employer might see in this work?
So communication is key. So in data science, the most important skill to have, regardless of what anyone else will say, is communication. You can be the best data scientist in the world and have all of the skills, but if you cannot communicate your ideas effectively to the people who make the decisions, you're not effective. And so, in my opinion anyway, I think a picture paints 1,000 words. Having good data visualization skills and being able to tell a story visually, be able to put together pieces of work that people can understand really quickly is really, really crucial for your career. And it's really crucial in data science in particular. You could probably apply that to anything, to be honest. Communication is important throughout life, but I think it's particularly important in tech and in data science. If I was hiring and someone came to me with this, I would be interested. As far as communicating it is concerned, I post a little bit on LinkedIn because why not? That's where people seem to go for recruitment stuff. I would probably link my Twitter account in my CV, but that's really it. I actually haven't really thought about how to sell it to employers. Again, to go back to what I was saying earlier, I haven't really. This has more been a hobby as opposed to I personally want to get something out of this in the future. I think selling the data visualization skills, I think it does a good job of doing that. And I think data visualization and communication is really important in data science generally. So I would be pretty confident that it will help if and when I decide to apply for another job. I probably won't for a long time, to be fair, because I really enjoy my current role.
I think that's a really good point you're raising there, because you're selling your visualization skills. And I don't think a lot of people think about this when they're applying for a job. I am selling my skills to a potential employer. So I need to convince them that my skills are worth paying for, essentially. And what are my skills? Okay, so maybe you're a data scientist, so you do some analytical work, you do some programming work, but you also do a bunch of communication. So these are the skills that I have. How do I sell them to the employer first? I guess you could almost see it like pitching an idea to some VCs, right? How do I get this message across quick and in a way that they can understand what it is that I can do for them?
Yeah, I agree. I completely agree. And one of the things that I've noticed is so, particularly when you're dealing with different departments in the company, they have a particular way of looking at the world. And one language that I think everybody does speak is a visual language. It's very easy you could present all of the numbers in the world in tables, in spreadsheets, in normal graphs, but it's very easy to just throw up a single image showing all of the data and people will instantly grasp it. So, for example, at Geolect, we're doing a lot of work in the Black Sea at the moment, trying to understand how the war in the Ukraine has altered shipping patterns in the Black Sea. And there are so many different things and metrics that you can look at. You can look at port statistics for ports in and around Ukraine and Russia. But in the end, what we did was we just took all of the AIS data that we had for the Black Sea and we made a shipping lanes map over time and just turned it into a GIF. And basically, what you see is that over time, the volume of traffic slowly but surely decreases to the point where there's very, very little going on in the Black Sea. And so you've taken something that is, millions of data points and just condensed it down into a single GIF that everybody instantly gets and understands. It also applies the context to it really nicely as well, which I think is really important. And that's a skill that it's not easy to get, it's not easy to do, but it's something that I think is really important to do.
Yeah, I mean, honestly, it makes complete sense to me. And I love maps. So you're preaching to the converted here. I just have a few more questions before we round off this conversation. The first one being, we've talked a lot about Python, and you've mentioned the reasons why you personally chose to learn it and focus on that as your primary tool, I guess, your primary language. But if you had to go and learn another language today, which one would you choose, and why would that be?
It's a good question. I would probably choose a low level language like C, simply because. So, Python is a high level language in the sense that it's very readable, but it's quite slow. And it's quite slow because there is a lot of code in the background that takes care of all of the complicated things for you, defining arrays and things like that, and defining, assigning memory, all of that sort of nonsense. There's a lot of code that takes care of that for you. So there's loads of other languages that are quite like Python, for example, R and Julia, which are similar in how they operate. I've learned both of them before, and I didn't think it was particularly difficult because I had that understanding of Python already. So if I had to go away and learn another language, I would want to learn something that was completely different to Python. And hence I would go for a lower level language like C, where you would have to learn and understand how to program in a much different way, arguably a more from a computer science point of view, a more correct way, I guess. Predefining variables, assigning memory, understanding how to optimize code. So I probably think about doing it that way around. But with that said, I'm quite into data visualization, so perhaps there's a flip side to it. That would be, as I like data visualization, learning JavaScript and actually learning how to build cool and interesting front end applications. Like Python maps would probably work pretty well if I could build a really cool website to show it all off. I have sort of tried this, but I'm just not skillful enough to pull it off yet. So yeah, there's two options. I'd either go for JavaScript or C.
So you mentioned this idea of computer science before, and it doesn't sound like you took that way of getting into your job. You're a lead data scientist now. It doesn't sound like you have a background in computer science. Do you think that you've missed out on something, or would you do things differently again if you could go back in time, knowing where you're likely to end up?
That's a seriously philosophical question. I don't know. I'm just a big believer in not looking back. I think I'm here. I'm where I am today because of the experiences that I've had and the people that I've met. I've often thought about whether I even needed to bother with my PhD because I think that the main thing I got out of my PhD was I met a lot of very, very clever, very, very driven and interesting people. And because I'm just naturally very competitive and I wanted to be as good as they were, that really pushed me to try and to learn Python, to develop my own cool and interesting analysis methods, to to write papers and to really try and just be as good as they were. I do often wonder if I would have had the same experience had I met similar people in a different field. Like if I'd just gone and got a job straight out of uni instead of doing my PhD, if I'd met the same sort of people, would things have turned out the same? The answer is I've no idea. Like I really don't know. But I really enjoyed all of the experiences that I've had that have led me to this point, and I'm pretty confident that if I needed to go away and learn computer science, I'm pretty confident I could probably pull it off. Who knows if I could actually do it or not? But I'm pretty confident. So I'd say I don't regret it. Okay, so like there would be things that would be much easier. I've got to the point in my data science career where I'm doing a lot of very on the edge things that aren't necessarily that well documented. At that stage, having a computer science understanding of what's going on would actually be really important because a lot of the sort of the cutting edge data science stuff is just computer science and it's really sort of heavy computer science. So maybe it might be useful, but what's the point in regrets? Just going to carry on.
I completely understand. Thank you very much for that open and honest answer. I appreciate it. I just want to say thank you very much for taking the time to talk with me today. I really appreciate it. You've been a wonderful guest, open, honest, and insightful. Everything I could ask for a guest on this podcast. So thanks. Where can people go if they want to reach out to you? If they want to ask questions, maybe if they want to follow along with Python maps, is there somewhere they can go to contact you or follow along in your journey?
The best place to get me would be Python Maps on Twitter. So just Python Maps, one word. I'm also on LinkedIn as well, Adam Symington on LinkedIn. Those are the two main places to get in contact with me. I actually do respond to my Twitter DMs. I quite like answering queries about Python because I'm just a bit of a nerd and I love Python. I will do my best to help out where possible if your question is achievable.
People can't ask for more than that. Really appreciate it. Thanks for your time, Adam.
Thank you.
So I really hope you enjoyed that conversation with Adam Symington. I'll put links to where you can connect with him in the show notes of this episode. Actually, there will be quite a few links in the show notes of this episode. So here are a few things I want to link to. So firstly, if you're listening to this and interested in learning more about Python, obviously that there's a ton of great online tutorials, but we've also recorded a few podcasts about it. So there'll be links to those podcast episodes. There'll also be links to some of the data that Adam was talking about. So he talked about Hydrosheds. I think this is a super interesting data set. You'll find a link to that in the show notes of this episode. So right at the start of this episode, I mentioned a email newsletter, actualcontrol.substack.com. There'll be a link to that as well. It's well worth checking out. If you're interested in supporting the podcast, there'll be a link to the Patreon. And any help you could give me with keeping this running would be greatly appreciated. So a lot of stuff in the show notes today. If you want to reach out to me for whatever reason, I'd love to connect with you. A great place to get a hold of me is on Twitter, @Mapscaping. I guess it's also worth mentioning that we have a website, mapscaping.com, and I work with an extremely talented freelancer who puts a ton of time and effort into making the best possible show notes. But if you're interested in more information, mapscaping.com is a great place to go. Okay, that's it for me. That's it for this episode of the Mapscaping podcast. Thanks so much for tuning in all the way to the end. It's much appreciated. I'll be back again next week, and hopefully I'll feel a little bit less sick. I'll see you then. Bye.